Hey, so I decided to build a solid-state guitar amp. Most parts were found in the bin and reused. Even the wires come from old, now repurposed ATX power supplies. I designed the preamp module in KiCad. It's based on a Randall RG100ES schematic, which is often associated with Pantera. I added an onboard DC to DC converter that is powered by a 12-volt supply line and outputs the required 24 volts. I also use different JFETs. Mine are marked 2N5457. Power amp section was also designed in KiCad and is based on a TDA7269A amplifier IC. The schematic used can be found in the datasheet under Bridge application. A single TLO71 op-amp is used in conjunction with an external pot to regulate the overall volume level. GBR files were exported and sent to JLC PCB. No affiliation. Upon receiving the boards, I assembled both units. The enclosure is an old network switch that I found in the garbage and decided to reuse it. It was gutted and here it remains. I'll keep the old switching power supply and fans, although a linear PSU would probably be preferred for such audio applications because it generates less noise at the expense of lower efficiency. I also added a power switch. An SPDT will suffice. Connected to this power supply is gonna be a beefy boost converter needed to power the TDA7269A IC. It's currently set to 20 volts and a built-in current limit has been set. Just in case. Some aluminum plates will be used to mount the modules and heatsinks. Close the panel gaps and add switches, pots and jacks. Excess wires will also need to be removed. Here we go. So there were some issues. First, I thought I'd use the existing power supply as it was rated for 150 watts, but what I failed to check is how many of those I'd actually be able to pull from the 12-volt rail. It was just under 10, so I had to replace the whole unit, as this wasn't enough to run the power amp. Once the power amp was up and running, however, it didn't cause any problems whatsoever. At least one of the cooling fans had a shot bearing and was making loud noises, so I got rid of them both as I didn't have a replacement. It turns out that passive cooling is sufficient. I'm using a very large chunk of aluminum profile after all, so no problems there. Then there were grounding issues. Protective earth and DC negative are both wired to the enclosure, and to get rid of some weird high-pitched noises I had to use an isolated input socket. I got rid of the second input socket that could reduce the signal intensity, as I never use it anyway. Clean sound is almost never needed, but should the need ever arise, I can still mount an additional socket here. Some of the regular switch sockets used in the effects loop on the back were faulty from the factory because I was too cheap to buy good ones. Lastly, the pin headers aren't too sturdy when using such chunky braided wires, and pressing down on them with a lead doesn't help either, so I fastened them with a dab of hot glue. Braided wires might look a bit chaotic, but I was hoping that the ground wire would act as a kind of shielding. Any protection from these two switchers inside I can get, I'll take it. Of course, a linear power supply would be more reasonable here, to minimize unwanted noise. At this point I just wanted to get this project done already, as it had taken me many dozens of hours. I took a slightly bigger bite than I could chew, so I had to get some professional help to get these problems sorted out, even though they now seem trivial. Identifying them is always the hardest part. The repairs were luckily simple this time. So would I do it again? I don't know, I don't regret it. It is one of the better sounding solid-state amps I've played in quite some time, and it will be a nice addition to my stack of amps. The Randall RG100ES had a great sounding preamp section, and at least it can be found online. So, if you understand these things better than I do, I'd say go for it. Thanks for watching.